This is Eshan Rao. I'm a PhD student from Indian Institute of Technology, Tirupati, and this is my 11th interaction session for data analytics with Python. So, since we are coming almost end to the week 12, today we are going to discuss about CART algorithms, that is classification regression trees. So the concept will be like, for 1 hour I will be speaking with few examples talking about basic decision trees, classification and regression, and followed by in next half I will code out one example on how to use decision tree with Python. We will doing the implementation part as well. So that being said, let's start. So let me share the screen. Getting shared. Okay, now just a minute. Okay, I hope you can see my screen. So let's start with some basic theory with some few basic example to get an intuition of what these algorithms are, and then followed by implementation. So that's what we are going to do in today's session. Okay, so first is this cart and algorithms. Basically, it has another name which we simply call as decision trees. These are decision trees only. There's nothing much fancy about it. Decision trees are basically of two types. That is, one is classification and regression. So we are going to build this classification regression tree. I'm going to give a basic intuition on these two type of trees, but mostly we will focus on classification trees. Okay, now how you can say that why they combine classification regression trees into one component of decision trees? Because of target variable. So we might have x number of independent variable, but our focus is target variable. Now a target variable, so for a classification, so if I have a classification tree is there and the target variable is to so target variable has some class labels uh, with finite set of values, then we can usually call as it's a classification problem. Okay, now that's the first part. Second part is regression. In regression, for the same class label, we predict some numerical value. We predict some numerical value, and this value that we are going to give for an output can be in infinite set of values. So for example, if I have a rain, so classification problem will be whether it will rain or not rain. This is a classification. That's a one way. Same problem regression is uh, it will rain greater than 2 mm. If 2 mm, how much? In that case, rain will be happen, but the amount of rain will be less than how much. So this will be considered as a regression, because here you are trying to give certain value for that, and this is just two classes where it will rain or not. That is true or false. So it comes as classification. Now all this come under decision tree. Decision tree will be based on that. You have n number of variables, uh, few independent variable and one target variable at that point of time. Which variables you have to give more importance? That too, in that importance, you have to ask for the aspect at what decision you have to split a certain variable. So let's take an example to get a better understanding for that. So let's assume that I have two fruits. So let's take one as orange, and there's a variation of orange, let's say mandarin. Okay, I'd both these fruits have same color. For demonstration I'm using two colors. Now I have a bunch of oranges, I have a bunch of mandarins there. Okay, and I just have to construct I need to construct a simple set of rules to identify or distinguish between these two fruits. So for that we have some data. So based on what kind of data we might have, so based on the observation of the data, based on certain assumptions, we can say that for oranges, the diameter of that fruit will be lie between 6 to 10 centimeter. For mandarin, it will be like diameter will be 4 to 8 centimeter. Okay, so this kind of one, suppose you have some data about this. From this, if you want to make one rule, how you can say it, like since orange will be bigger than mandarin, you might say first rule as diameter is less than equal to 7 centimeter, assuming that 6 and 7, like 7 is between these two, I'm assuming that 7 centimeter will be there. Okay, so that's a one rule we can make like that. Rules can be infinite, you can make, but for the sake of this example we are making like this. That's the first rule. Now the second aspect, the second data we might have is mandarin are slightly darker than oranges. Okay, so let's assume that if we are giving a dark scale for that how dark a color will be, so we might say 1 equal to dark and 10 equal to light color. So in any of these things, we might say that if it is less number, that means a dark color fruit. If it's 10 near to 10 in the scale of 10, it might be light color fruit. And since but at the same time, this is not exact, we can say that like there might be chance that orange sometime might be has darker uh, darker color, similar color to mandarin, or vice versa. So in that case, we have to make certain rules. So if we have this data, so what two rules we can make, 2 3 rules we can make based on that. So the rule will be like second rule. Second rule, we can say if color is less than 5. Okay, so if color is a little darker in a darker shade, so we can say that left side of subtree, or this like true or false, we can assume that their left side of subtree, they are basically mandarins. We can assume like that, or we can remove this. Now third rule, something like that, if we assume that okay, but there still might be instances if color is greater than less than equal to 5 is there, so obviously greater might be much lighter color fruit, so we might say that they might be oranges. There's another thing we can do is, now this is at a threshold of 5, but I might say that a threshold of 7, if it's like that, so I might create a right side of the tree subtree, and if the color is still less than that, I might still consider that as a mandarin with certain probability. Okay, so I'm just giving an equal opportunity, because opposite of this is already we are assuming that if color is greater than this, we might say it's orange, or if it is less than that, so we are just creating different options, and the options can be as many as possible. So we just have to see which rules might best fit for us. So since this is an example, we are just assuming certain part of it, but basically, but based on the data what we are going to have, based on that we have to define set of rules. Uh, Now, if we have this kind of rules, so there we have 3 rules. So rules are, that is, one is based on diameter and two rules based on color. So one is like diameter is less than 7 centimeters, second rule color is, and the color shade is less than 5 or color shade less than 7, something like that. Now if you have to make a general without any probability that what the food will be like, and you just have to say, you have to make a decision tree. So what we have to do is we have to take one rule as a root rule. So in this case, let me take this. So I have to start with certain rules. So let's assume that I am taking rule number 1, that is diameter is less than equal to 7 centimeter. I will take this as a root node, or you can say root rule. That is root node or root rule. That is basically I'm saying that irrespective of whatever the condition I will be getting with respect to whatever data I am having, the first rule I have to check that what is the size of that fruit. Okay, now if it will consider as true or false, because I'm looking at categorical data. So in this category, like this condition might be true or might be false. If that is there, then I will say let apply rule number 2, rule 2, that is color of that fruit will be less than 5. Okay, so if that is true, we know that mandarins are more darker than orange, so we might say mandarins. If it is false, okay, if the color is not less than 5 but diameter is still less than that, then we can say it's orange. Okay, that's one way. False, let's say the diameter is greater than 7 centimeter, so we might apply the rule 3, that is color is less than equal to 6, because mandarin might also be an average. We have seen 8 centimeter in the range, so let's assume like that. So let's see that diameter is greater than 7 centimeter, and at the same time rule color of that fruit is less than 6, that is might be darker. So if it is true, I might say it's a mandarin, and if it is false, that is its color is greater than 6, I might say it's a lighter color, so I might say orange. So based on the whatever data we are having, we can construct this decision tree. Now the important thing is here we are only focusing on rules and like that, but we have to consider certain other aspect. So what are those aspects? Now I have taken color less than 5 or color is less than equal to 6. So the natural question that we should ask is how does this decision tree or CART algorithm find the best split? When we say best split means, like I have a scale of 1 to 10, so I can split this scale at any point, right? Why should I even consider 5 or 6? I might consider 3 or 8 or some other number. So why should consider that? For that we have a metric which help us understanding that, which is called as Gini impurity. So what this will do is Gini impurity will be, it's like 1 minus probability of that a particular condition is true square minus probability that particular condition, the rule in this case, is false, that square. Okay, we can write it this in this way also, 1 minus sigma I raised to 1 to n and pi square. Here I in this case will be the number of classes. Here I have only mandarin and orange, but I might have some different type of oranges as well. So at that time I might have more number of different kind of changes and probabilities. For that I need to have different kind of probabilities. For that I can calculate using Gini impurity. Okay, now I will show you in while solving example how you can calculate it, but just to get an idea that if you want to know that at what, if you have to create a rule and you have to find it, okay, at this threshold I need to spread the data into this half, at that time you might use Gini impurity. So the less impure, so the less if you have a rule where you have a data with less impurity, you select that input. If it is high impurity, you try to ignore that rule. Okay, so that's how you can do this. And there's something called as weighted Gini impurity. I will discuss that while solving the example. It's just a combination of uh, multiple combination within a particular rule. At that time we use weighted Gini impurity. I will solve that using one example. Okay, there's one thing. Another thing that people use, this is highly used, but there's another metric also which is called entropy, which is not much difference with the concept of the probability of getting a rule correct or probability of getting a rule incorrect. In that case, it just give a different kind of formula, that is sigma minus sigma of I from I to n, probability of particular class, that is particular class might be, we are saying that it's true, with log base to pi. uh, you just don't have to remember, you might just remember it for the sake of understanding that what are different methods to understand that whether the R decision tree is it's better or not. For that, Gini impurity, entropy, and uh, other kind of metrics are present. Okay, but mostly we will use Gini impurity in this case because it's simple to understand and simple to interpret the data as well. Okay, so that being said, this is the overall of just getting introduction of CART algorithm. This is basically CART algorithms are basically decision trees. It has two variations, that is classification and regression. Okay, we just talk about if I have orange and mandarin as two fruits, and based on that, how can I make a decision tree out of it. So I made a decision tree based on the diameter and the color of the fruit. Okay, now what we'll do, let's take a basic example to see that how it can be worked properly, how we can calculate all this value. So the first example, I will not talk anything about the Gini impurity. I will just talk about basic, based on basic data that we are having, we make a basic decision tree. In the next example, we might look at the Gini impurity as well. Okay, now so we have a play tennis data set, so which and we have to apply decision algorithm to find optimal decision tree. So our thing is, we have four variables like outlook, temperature, humidity, and wind, and we are saying that whether we will play tennis on that day or not. Okay, so we might have, it's all a categorical data. So outlook has three variables, that is called sunny, overcast, and rainy. Temperature, we have three type of temperature: hot, mild, and cool. Humidity is high and normal. Windy is false or true or false, like whether that day it's windy or not, and whether we are playing tennis based on the other these four criteria or not. So we will check all these four criteria to check whether we can whether we can play tennis or not. Okay, so that's our this thing will be, and we will try to see that. Now if I get some out as a out input, like I have a day sunny, it's a sunny day and temperature is hot and humidity is normal and wind is following, then whether I can play tennis or not. So we will check that how we can solve this. So let me, so by hand when we are solving it, we have to look at each and every variable and its relation with the target variable. So I will look the relation between outlook and play first. Then first I will check this. Then I might check for relationship between temperature and play, then humidity and play, and windy and play. So I will try to understand the relationship between them, so that for a particular kind of outlook, what is the play I am getting, whether I can play tennis or not. Similarly for what at particular type of temperature, whether I can play a tennis or not. So I will try to form a relationship between them. So how we can do that, let's see. So let's see the variable is, first is outlook. Now outlook has three type of classes. In this case we can say it has sunny, overcast, and rainy. So let me write it down here. So I might have overcast, sunny, and rainy. Okay, now once I have this, I will now try to check what are the number of instances I might have for each of these categories. So each of these categories, so let's say overcast will be 1, 2, 3 and 4. I have 4 overcast, sunny, 1, 2, 3, 4, 5. 5 sunny and rainy, 1, 2, 3, 4, 5. So I have 14 samples data. So in that, for a particular one variable, I have overcast as 5, sunny as 5 instances, rainy as 5 instances for one variable. Okay. Now what I have to see is in how many instances of overcast this play variable, in this play variable, I can play. If it is yes, that means I can play with overcast thing. If it is no, that means I can't play in the overcast setting. So I'm finding the relationship between that. So I'm counting the number of instances for this. So let's look at the table. So what I have to check is for overcast. For if I have overcast, I have to check how if I have overcast as an outlook, whether I can play or not. So at one instance I can play. So yes is one. In second overcast instance I can play. In third overcast system I can play, and fourth overcast system I can play. So that means for all the instances, if I have a day like overcast, then and all these days I can play. So what I have to fill is I can play. I can write it as 4 and 0. Okay. Now for sunny, let's see sunny. If I have a sunny outlook, then I might not play. Sunny outlook I might not play. Another sunny outlook I might not play. But in this one, in one of the data instances, I have find sunny is there, and I found that I can play this thing. So in another instance with sunny I can play. So what we have found here is in 5 instances, uh, at 2 instances I can play the tennis, in 3 instances I can't play the tennis. Similarly for rain, if I have a rain outlook, so at rain outlook I can play, rain outlook I can play. For these two I can play. At one rainy output I can't play. For one instance of rain I can play, and another instance of rain I can't play. So if I put this, I will just write 3 and 2. Okay. Now I got one data based on that. So what will happen is, now once I have this thing with one variable, that means with 3 classes of with outlook, overcast, sunny, and rain, and I have found that what are the instances where I can play the tennis and what instances I can't play the tennis. So what we have to do is we have to make rules. I have to make certain rules based on the data that I am having. So for the attribute rules, let's try to make dominant rules for each of these classes. So let's start with overcast. Now with overcast, what we have find is, let's write overcast. Now I have to see that which rule is more dominant or which is more in my favor to predict the outcome. So in this case, I am finding that if for 4 instances, if my outcome, if overcast is there and I give it that tennis playing yes, I have 4 instances. But if I have overcast and I can't play the tennis, it has 0 instances. So for me to predict that, given a overcast as one of the input, I can say that I can play the tennis. So this will be my dominant rule in this case. So I will say this rule might be better suitable for me to put it into the decision tree. So if once I have this, the error that I am having. So what kind of error? This is a combination of all the observation of overcast. In this, if I put overcast and then and give that output that yes I can play a tennis, the error is actually 0 in this case. So I will write 0 by 4. That at 0 instances I might give a wrong output that I might not play a tennis or I might play a tennis. If you're not able to understand it, let's look at the second class called sunny. Now if I have a sunny as a class, so I have to see that I have 5 instances. So I have to see out of yes and no, that is yes is playing the tennis and 3 is not playing a tennis, which one is more dominant, or which one, from which data I can get a much better prediction. So I found that in 3 instances, if I say sunny and I can't play a tennis, I found that 3 instances I can predict the instance correctly, and for 2 instances I might not able to predict it correctly. Since 3 is more than 2, that's why I'm writing as I will choose the rule as sunny as a day, and I can't play a tennis. So in this case, the error here would be 2 by 5. Why 2 by 5? Overall, I have 5 instances, and out of 5 instances, for this Sunny equal tends to no, I found that at 2 instances I might write at incorrect data. I might predict it incorrectly. That's why error is 2 by 5. Similarly, if I have a rainy as a day, whether I can play or not. So I found that I have more yes instance playing a tennis as an instance I have more compared to no. So I might write, if it's raining, I may still play a tennis, but the error in this case still will be 2 by 5. That is, out of 5 instances, at 2 instances I might predict it as a wrong. Okay, so once I get some errors with respect to the yes and no, with respect to whether I can play a tennis or not, I will combine them, and I will write it as the overall total error. So in this case, the error will be 4 by 14 in my case. Why 4 by 14? That means out of 14 instances, there might be 4 instances where I am predicting wrong. So this is the total error that I might get. Okay, now this value is more important because we are going to calculate this total error for each of the variable, that is in this case outlook. Now next will be temperature. So like that we'll calculate for each and every variable, and we will see that which one give us less error. Okay, so let me do it for another one to get a better understanding, then I will fill out the rest of the table. Now in variable 2, that is temperature. In temperature I have 3 different type of classes, that is hot, mild and cool. So let me write it down here. So I have hot, mild and cold temperature. So I have 3 classes in this case. Now once I have 3 classes, let me find number of instances I am having here. So for hot it will like 1 2 3 4. Okay, and mild 1 2 3 4 5 6. Cold 1 2 3 4. So I have instances of 4 6 4. Okay, now once I have this, now I have to see in what conditions of playing a tennis I can do. So yes means I can play a tennis, and no means I can't play a tennis. So for hot, let me find it out. If I have a temperature is hot, I can't play a tennis. If I have a temperature hot, I can't play a tennis. If I have temperature hot, I can play a tennis. If a temperature is hot, I can play a tennis. So I have two instances. I have two instances where I can play, and there are two instances where I can't play the tennis. Okay. Similarly, for mild temperature, let's see. So if I have a mild temperature, I can play the tennis. If I am mild, I can't play the tennis. Mild 1 2 3 3, all the 3 time I can play a tennis, and this last mild I can't play a tennis. So in this case I found that at 4 instances I can play a tennis, and 2 instances I can't play the tennis. Okay, now for cold, that is cool here. So cool I can play tennis, for cool I can't play, for cool I can play, and there's another cool I can play. So in this case, out of 4 instances of cool temperature, in 3 instances I can play, and 1 instance I can't play. So once I got this data, again I'm trying to find this type of total errors, which will help me to understand from the data, if I make certain rules, how can I minimize the particular error. Okay, so let's start with hot. So if I have a hot as the temperature, and I have to see whether I can play this or not, I have seen here two instances are there. So either though I can say hot equal tends to no tennis, or hot tends to yes I can play a tennis. Might be it will be same, because both has equal number of instances within the data, but the error will be 2 by 4, because out of 4 instances, every time I give 4 instances, 2 will tend to be wrong. That's why the error will be 2 by 4. Now for mild, in mild, most of the condition I see that at 4 instances I can play the tennis only in 2 instances I can't play. So I will say that if the temperature is mild, I will mostly try to categorize that I can play a tennis. So if I do that, the error will be here 2 by 6, because for only 2 instances I might not be able to predict it properly. Now for the cold, 3 instances I can play, so I will, it's a dominant one, so I can predict it more better, so I will write 1. At 1 instant I can't predict it properly, so I will write 1 by 4. So total error will be 2 plus 2 plus 1, it will be like 5 by 14. Okay, so that's how we can say for temperature, it's the total errors that I'm getting if I'm trying to predict only with temperature is 5 by 14 errors I'm having. Same with outlook, if I'm taking only outlook as one of the variable, then I'm saying that 4 by 14, 4 instances out of 14 I might predict wrong. Okay, so similarly for humidity I will write it down. So humidity has only high and normal, and it has 7 instances each. So I solved it earlier, so I'm just filling up this this thing. Now if I have to make the rules, so for high and normal, okay, in high out at 4 instances I might not able to play the tennis. This is higher than the playing the tennis, so I will write in this case 4 by 3. Say high, when the humidity is high I might not play the tennis, and the error will be 3 by 7, that these 3 instances where I am predicting that I can play a tennis. For normal, at 6 instances I can play a tennis, only 1 instances I can't play. So I will put normal. If I have a normal humidity, then I can play a tennis. Only at one point I might get it wrong. So I have a total error of 1 by 14. Now once I have this, for windy I have only false and true, two values, in which 8 values are false and 6 values, like that day it's windy, and one true might be sorry, false means the day is not windy, and the true means it is windy. So for that I will keep 6, like based on the earlier calculation that I have done, it is like this. So if I have to make rules out of that, I will check which one is more dominant. So if it's true, I have seen that it's equal, whether I keep first or second, it doesn't matter. So you can put any of these rules, true equal to no or yes, the result will not change, but the error will be 3 by 6. But if it's not windy that day, I have dominant yes is there, so I will just keep. If I have a false, if there's no windy, I will play a tennis for sure. So but in that the error will be 2 by 8. So error in total will be 5 by 14. Okay, now once we have this, so the first stage decision tree will be there. So what the first stage decision tree will be, for from each attribute that I'm having, that is temperature, outlook, humidity and windy, from that I will try to predict whether I can play the tennis or not. Okay, now how to do that? Okay, okay, so to do that, what I have to check is, now I have to check the total errors. Okay, now I have to check total errors, that is 5 by 14, 4 by 14, in this case 4 by 14 and 5 by 14. Now what I have to look at is, I have to look for the least total error, because I want to minimize my error while creating a decision tree. So I found that I have two variables, that is one is outlook and the another variable is humidity. So these two variables has least error. So now I have to find which variable I have to take. Now once I check the variables, that is I found that outlook and humidity have almost same error. Then I have what I have to look. I have to look for the individual classes, because each attribute has its own classes. So at that point of time, I will look out for the individual classes. Like in this outlook, I will look out for overcast, sunny and rainy, and in humidity I will look out for high and normal humidity. In this, what I have to check for individual classes, what I have to check is, I have to check that which class give me least error. Okay, so in this case I found that error for overcast, I found the least error. Why? Because it is for overcast, it is perfectly predicting that whether I can play the tennis or not. So the number of zero errors I am having is 0. But if the number of errors are not 0, then you have to check for the least error. That is, in this case, maybe 1 by 5, 2 by 5, or 1 by 7, like that. So you have to check for least error. Now, considering that we have already have a variable overcast which has perfectly predicting that whether I can play a tennis or not, I will choose outlook as first variable. That will consider as the first root variable that I will going to take. So how it will, so to make the tree, how it would look like. So I will take outlook. Now outlook has 3 classes. So one is overcast, sunny, and rainy. Okay. Now if I put overcast, it will directly give me yes. So if yes is there, that means I can play a tennis. But now the other two variables, the other remaining variables for sunny, where we're going to look at is temperature, humidity, and wind. Same here as well, temperature, humidity, and wind. Now what does it means is, I'm going to make a separate sub decision tree here. Sub decision tree I'm going to make with whatever the remaining data I'm having. So I will only, now if I am looking for outlook, this is my root node. Okay, this is the first criteria I'm going to look at for. Now once I'm looking for root node, I will check the further table which contains only sunny days, or I will look at for the instances where its outlook is only rainy. Then from that I will try to make the decision tree, sub decision tree from this. So here, so stage 2 of decision tree in this case will be that when my outlook is sunny, I have 5 instances. So we have just put that instances here. Similarly, if my outlook is rainy, then these are the 5 other instances from the same table that we are having. So that's how we are, when we are creating subtrees, you observe that the data that we are considering will become less. We are not going to look at the whole data. We are going to look only at the specific data. Okay, so this is for the instances where my outlook is sunny. Now from here again, what I have to repeat the same procedure where I have to check for temperature, that is I have to look out for each classes, and I have to check the total error I am getting, and I have to find the least error that I'm able to get from that. Okay, so I have done this calculation earlier, so let me write it down quickly here. So I have 3 classes, that is hot, mild, and cool. So the kind of rules that we are able to make here is, the temperature is hot and I can't play. So in this, the temperature is hot and I can't play. So in this case, errors are 0. So 0 by 2 I'm having. Now mild is only has 1 instances. So it's so we can directly write as no. So the error is 0 by 1. And for, sorry, mild is 2, right? Okay, sorry, my mistake. So I can take no or yes, any on this thing. The errors will be 1 by 2. Okay, now for cool, I have only one instance available, which is yes. So I will write cool. If I have a cool temperature, I can play the tennis. So in this case, the error will be 0 by 1. Okay, now the total error in this case will be 1 by 5. Okay, so that's how we can calculate for others thing as well. Let me write it down. Humidity has two classes, high and normal. So if I have a high humidity, I might not play. If I have normal humidity, I can play. In this, I have 3 instances, and for normal, I have only 2 instances, and the total is 0 by 5. That is it predicting correctly. For windy, I have true or false. In true or false classes, if it is false, then if the wind is not there, I might not play. If it is there, then I might play or not play, because I have same number of instances. So error here in this case will be 1 by 3, and the true will be 1 by 2. Okay, so overall is total is 2 by 5 error. So this is only for sunny. Same, we have to look for rainy as well. So let me write it down quickly. So for temperature value, mild, cool, and hot, So hot is not this in this case, so I might not write hot. So hot is out of the picture in this case. So I will only look at only these two classes, mild and cool, for temperature. So in this case, I found that if it's these are temperature there, I can play a tennis. So in this, the errors are 1 by 2, 1 by 3 and 1 by 2 respectively, and the error is 2 by 5. For humidity, it's high. If I have a humidity high, I can't play the tennis. If it's normal, I can play the tennis. So it's 1 by 3 and say 1 by 2, and it has 1 by 3. So it's like 1 by 5. Say 2 by 5. Okay. Now for windy, it's false. Yes. True. I can play. Then for these, I have exact correct instances. So it's like 0 by 5. Okay, now once you fill this kind of table, what you have to observe is the least error. So for sunny, I have found 0 by 5, that is humidity is a perfect variable for me. And for rainy, wind is a perfect variable because I have the least total error. So if I have to make final decision tree based on that, I will just start with Outlook. Outlook, in this I have overcast. If I have a overcast, then I can play the tennis. Yes, I can play the tennis. Okay, now let's go for sunny. If I have a sunny outlook, then I found that in this case humidity. If it is sunny, then I have to look for the humidity. So how will write as humidity as a variable. In this, I will check whether humidity is there or not, whether his humidity is high or it's normal. Okay, if humidity is high, then no, I can't play. If it is normal, yes, I can play. Okay, similarly for rain, rainy outlook, I will check for, if it's raining, then I will check for wind because I have total error as 0. So I will look for wind. So I will just like it's called wind. Okay, here I will check for whether it's windy or not, or that is true or false. If it's true, it's windy, then no, I can't play the tennis. If it is not windy, then yes, I can play the tennis. So this is the final decision tree. No means I can't play, yes means I can play the tennis. Now if you observe, we have 4 independent variable, and here I haven't included temperature anywhere, which is perfectly fine because based on the whatever the process that we observe, temperature doesn't have as big role as compared to outlook, humidity and wind. So it's perfectly fine. Sometimes when you're making a decision tree, you might exclude certain variable because they might not have as significant impact as humidity and wind. Okay, so we are excluding temperature, and this will be the final this will be a final decision tree based on whatever data we have. Now how to check that whether it's correct, how to predict now. So we have one example. So you're asking that if my outlook is sunny, temperature is hot, humidity is normal and wind is true, whether I can play or not, that's the question. So you have to trace it back. So I have to check that outlook is sunny, so I will go for this side. Okay, the temperature is hot, I can't do much about anything here because I don't have. Now for humidity, it is normal and wind is true. Okay, now I have only now it's since sun is there, I can only check humidity. So I will check for humidity, and humidity it's saying that it has to be normal. So it's given condition is normal. So based on only 2 factors, we can define that yes, I can play a tennis. That is outlook and humidity. We are not even considering temperature and wind in this case. Okay, so that's how the decision tree works in a simple setting with based data that we are having. Okay. So that's about the first example of this. If you have any doubt, please reach out to me or take some time to observe it. So to in summarize, what we have done is we have some data. Now we have to make a decision tree out of it. So what we are doing is we know the target variable. We have to find the first important variable from where we can start a root node, that is the start our decision making process. So what we will do, for each independent variable we try to find a correlationship with the target variable, and we try to find which independent variable will give us less error. Okay, so for that we have built this table, and along with that rules we have made to find which independent variable will give us less errors. Okay, and when each variable might have different classes as well, so we are calculating that, and we found that Outlook is the best choice for us. Now once we have best choice, then the first stage of this thing will be there, and Outlook has 3 classes, so we have overcast, rainy and sunny. If you have n number classes, you might find n number of nodes based on the data that we are having. So if we just say that if we just directly say that for given input my Outlook is overcast, then you can directly say it can play. Okay, but if we have other things like sunny or rainy, then we have to find the other different sub decision trees. To find sub decision trees, you have to collect those particular instances from where you are trying to build the decision tree. So for example, for sunny and rainy, we extracted the particular instances from the main data, and then again we try to find the particular kind of we again trying to find the particular kind of variables which can affect or help us to identify which variable will help us to find uh, the value of target variable with least number of errors. So that's how we ended up doing this final decision tree. Okay. Okay, so let's right now if you have any question, let me check. Okay, depth of decision tree. Okay, so depth of decision tree comes down. I can better understand, be able to help you understand with regression tree data, but let's try to understand in this itself. So depth of the decision tree, it comes down to how you're making the rules. So how you're making the rules means you might so suppose you have 20 observations, okay, and for all 20 observations you might make a decision tree which can fit all the observations, something like that. So you might have something like this. So each node will have a rule in this case, okay, and these are something called as leaf node, where you have the final decision of target variable. So for all these 20 observation, you might find each and every rule. You might put certain threshold threshold to say that okay, after this threshold you can get this type of output, after this threshold you might get this type of output. So if you do such kind of thing, there's a concept called overfitting will happen. What you mean by overfitting is that decision tree is able to correctly predict all the current observation, 20 observation, but if I get a new data, there's a high chance that it might not predict the new input incorrectly. Okay, so at this kind of thing, we don't want to overfit the data. We don't want exactly to learn each and every aspect of the observation. We just need a higher observation value. So at that point of time, the depth of the tree will be defined. So depth of the tree will be defined as when you're trying to create a threshold. So you'll try to see, it contains some multiple factors, but if I have a 20 observation, you will say that once I'm creating the rules, I will check that the number of observation that I'm considering within that subtree. So for example, once we made we had this data has 14 observations, okay, 14 observation, but once I made the first stage decision tree, I am just reduced down to 5 observation each for sunny and rainy. Okay, now if I try to make more rules, it might go less down to 5 observation to 2 observation, 1 observation, but I have the option to stop here. So I will say that okay, if after I made this rule, if I make more rules, then the number of observation will be less. So I will say that after this number of x number of observation, I will stop splitting the data. Okay, so after that I will not do anything. So in this case somehow our thing works out, but in most of the cases you might go more and more deeper, and you might find more and more rules for that. So there you have to look out for splitting of the data. So when you're saying depth, it depths down to splitting of the observation, splitting of observation points to make new rules. Okay, so you have to put some threshold that okay, the least number of observation I should have for a particular rule would be 5 or would be 10 out of n number of observation that you have. So that is something you have to define. Once you define it, the depth of the tree will be automatically arranged and try to give better decisions. That's what we call. So once okay, let me explain the regression tree now. Based on that, you might be able to understand the depth of the tree much better. I hope with this example you might be able to understand the depth of the tree. If not, let me explain the regression tree as well. After that, we will take one short break. I will solve this thing later with Gini impurity. Let me take regression decision tree. Okay, uh, so let's assume right now that we have created a medicine. So there's a medicine, okay, which can cure common cold. Okay, now the problem is we don't know the optimal dosage that we have to give to a patient, okay. Now we have this data, so we have this problem. So what we did is we did some clinical trials for that. Okay, now for with different dosages. So let's assume one scenario that I have drug dosage here and I'm checking the drug effectiveness in terms of percentage. Okay, so drug dosage will be like 10 mg, 20 mg, 30 mg, 40 mg, like that. Effectiveness will be like 25% effectiveness, 50%, 75%, 100%, like that. Now if I have this, I do some clinical trials. So one scenario will be like that as I'm increasing my drug dosage, the effectiveness is also increasing. So what I will do, I can directly fit the line like this. Okay, so that means higher dose means higher effectiveness. Okay, so this is a kind of scenario that we usually see in linear regression settings typically, but since usually we not find such kind of instances, so what we'll do is let's take another kind of scenario. So in this I again have a drug dosage, I have drug effectiveness. So same 10, 20, 30, 40, 25%, 50%, 75 and 100. But in this scenario, my data point will look like this. Something like this, and here something like this. So it's very so I can't fit a line. So if I try to fit a line in this case, my average will be somewhere here. Okay, if I do like this, it is a very it give me a very bad classification or regression with respect to this, because if I'm, let's say, 25 mg of dosage, my effectiveness would be around less than 50%, maybe 45-40, but according to data I am finding that it is more than 50%. Okay, so at this point of time, linear regression might not help us. So what we can do is we can try to make a decision tree. Decision, like with respect to different kind of threshold, we can try to make a decision tree. Okay, so how we can do is, so we can do a kind of experiments with respect to this. So how I can start is, I will start with this. So let's say like this. So I'm taking first two dosage. So my average drug dosage is 3 mg, is less than 3 mg. Okay, so I might term it as dosage which is less than 3 mg. So I can, so the drug effectiveness on an average might have average is equal to 0, and let's assume like it's around 35 something, 38 point something like that. Okay, now what we have to do is, in regression kind of settings, we have to find a correct partition. Okay, now what I have to see is the average drug effectiveness that I am having, in this case 38.8, or average is 0. Okay, but as we have seen, if you try to fit line like this, there are a lot of errors that I can calculate. So we have to calculate the errors with respect to that. So how we can do it? We can do it using residuals. There is something called residual, that is mean square of errors. So what does it means is, if I try, so let's say I try to get an average dosage something like this and try to fit a line like this, I will try to calculate the error with respect to actual and predicted value. Okay, so I will try to calculate all the errors between these points. Okay, so if I try to do that with dosage equals the with particular dosage value, I might get different kind of residual value or sum of squared mean error. So what I can, if I have to try to plot the data, so dosage of threshold for tree, so I might have 10, 20, 30 and 40, and sum of square errors, square residual. So square residual will be average minus whatever the actual value is there. Okay, so for this, the value once we calculate is around 27.468.5, something like that is there. So my scale will be bigger here, in this case 15,000 and 30,000, like that. Okay, now what I'm going to do here is, I will keep on changing this value, that is 3. That means right now my average dosage is 3. Now I will change it to maybe 5, maybe 9, maybe 10, maybe 12, maybe 14, maybe 20, 35, like that. I will keep on changing till the whatever the higher value I am having. With all this value, what I am going to see this average drug effectiveness for both the side. So if I have dosage less than a particular threshold value, what is my average effectiveness of both the cases? And I'm going to plot the data here. So once I plot the data, what I found is, like at certain point, I will get some minimum threshold value. After that, it will again increase till certain point, and again it will decrease, something like this. So I have to focus on this particular threshold point, which is the least minimum, which gives me a least sum of square residual. Okay, now once I calculated this, I found that dosage at 14.5, this is smallest residual I am having, that is smallest least number of errors I am having. So let's suppose 14 is here, so something like this. So my decision tree first look like dosage less than 14.5, because it is a least residual I am getting. So I might say that the left side and right side. So then I might find the average effectiveness, but I will not stop here. Once I get this, now what I will do, now once I get this, I will focus on this region, the red highlighted region. Then here I will try to find a more threshold. So the threshold will be uh, like for dosage less than 11.5, my average effectiveness will be somehow maybe 20, for example. Or if my dosage is less than 9, because less than 11.5, my average will be maybe average is 5, and again average will be equal to 0, something like that. Now once I try to do this, since a numerical value, I can extend it more and more till I find only singular value, like average 20, average 5, something like that. Okay, if I do this, this is called overfitting. Okay, this is called overfitting. That what I'm trying to do, already I might already have 5 to 6 observation here, and what I'm doing, I'm trying to fit all this observation with different kind of threshold. That means I am trying to make different threshold to calculate the average effectiveness, and that which I'm showing with green line. Okay, I'm trying to calculate what is the average effectiveness will be like. So what, because of which what will happen is, whenever I'm having dosage which is within this kind of range, I can directly say give average effectiveness. But if I have a value dosage within between this 11.5 and 9.5, I might get a wrong answer for that. So that's why it's called overfitting. Here I have to, what I have to do, I have to put a split threshold. Split threshold means I have to make it explicit to the classifier or the decision tree, uh, that number of observation, the minimum number of observation I might have for each rule. So if the number of observation after splitting the data, if the number of observation is less than that threshold, I can't make new rules. I will stop there. That's how I might understand the depth of the decision tree. That is one way of doing it. Or directly you can say that uh, in the, if you directly doing the coding, you can directly say that, okay, I need only 2 depth or 3 depth of things. So after, that means after make, if I have my depth is 3, something like this, what I will say is, from the root node I can make only 3 more rules, not more than that at each layer. I might not go below than this. Even though my observation is might be high, I might restrict here. Okay, I might go till here, like this. I can extend horizontally, but vertically I will say that my maximum depth of the tree would be like this. Okay, even though my observation will be, after this might be 100 observation or more than that. So there are two ways of looking at it. Either you define the number of splits, that number of observation after each route, that minimum number of observation should be present. If it breach that, then you stop splitting the data, or you explicitly said that 3 depths, that means from root node max to max rule, number of rules that I can make till a particular vertical length will be 3. Okay, I will not make more than that. So that these are two ways of identifying the depth of the tree. Okay, so split, and that you directly assume that this depth of the tree will be like this. Okay, so based on that that example that we are having here, this kind of example, let me draw it one more time. And something like this. If I have this and I have to make a classifier based on that, based on regression classifier, like based on actual data we have taken this, so it will be like, I will just do effectiveness. I'll just make the final decision tree, and then I will say what I did here. Dosage is less than 23.5. This is 2.5 effectiveness. 52.8% effectiveness, and this is 100% effectiveness. So the number of observation that I had earlier in this may be about 20 plus. Okay, so what we did, we started with dosage which less than 14.5. Okay, now in this, the number of observation I might have is 5 to 6, and I put the criteria of split will be equal to 7. So if I have, once I'm making a rule and the number of observation which is, if it is less than 7, then I can't make new rules, so I will stop it there. So what I found that once I make dosage is less than 14.5, the draft effectiveness based on this data, average effectiveness is 4.2. Now since I have this, the right side, I have more than 7 number of observations. So what I will do, I will try to split the data. So I will go here. here what I am doing, I am trying to split the data from here, that is dosage which is greater than 29. So once I am having this, if it is true that dosage is greater than 29, I found that it's 2.5% of effectiveness. Okay, but still I have the data within this lying region, uh, highlighted green region, which is greater than 7 observation. So again I make a rule, that is if dosage is greater than or equal to 23.5, that is this region they're asking for, something like this region, then I will see that effectiveness of 52.8. If it is false, then I will say as 100% effectiveness. Here some 100% effectiveness was there. Okay, one more rule, that is it's by default, it's not rule but it's a written kind of thing. If you are trying to make a decision tree, your left subtree will be true and right subtree will be false all the time. Okay, so that is if they are not giving anything, assume that left subtree is true and right subtree is false all the time. Okay, so that's an unwritten rule, or that's how the convention people make. Even the if once I show you the implementation of the code as well, there also true and false will be based on that. Okay, so I hope you able to understand till this point. So right now we have discussed the classification problem, decision tree and regression problem on overview. What now we will do here is we will take a 10 minutes break. So maybe we'll come back by 7. It's already 7:10. So we'll come back by 7:17, something like that. Then I will show you the implementation of the decision tree for the classification decision tree. I will show you for that. Okay, then we will wind up the session. So if you have any question, please type down in the chat and I'll just come back in 2 minutes. And we will start the session at 7:17. Okay. Okay, hello everyone. I have shared the Google Colab notebook and the dataset that we are going to use for the implementation of the this CART algorithm. So let's start with that. So I'm going to make let me share the screen also first. The decision tree based on that data we are having. Yeah. Okay. Now, so there's a data set of of weather which is taken from the Australia. This is a famous data set which we are going to use. With it has lots of attributes, 17 features, plus thousands of data. Based on that, we are trying to make a decision tree. Now, decision tree will be it tells basically only thing that whether tomorrow whether it's going to rain or not. So on that part we are going to work on. Okay, so some basic libraries, and I have shared the data set as well. So this weather AUS data set is there. I will show you what are the contents of that. So few basic libraries, pandas and numpy for dealing with the data, sklearn for model selection, train test split for training and testing the data, classification report for accuracy and all. For decision tree, there's a class called tree. Directly we are doing that. Now Plotty is Plotty is basically a library for 3D visualization. Just for the names that you don't have, so I'll just show you one 3D code, the plotation code that we have written, which you can use to plot and try to understand the data. We use that, and we use Graphis to show that how the decision tree has been made with the whatever data that we are having. Okay, now the first thing is to collect more data, say to store the data in pandas. So first, before, since it has lot of features, around 20 plus features, something like that. So I'm just doing one setting here to display more columns. Okay, so it will like pd dot option dot display dot max column equal to 50. I can show the max column 50 is something like that. Now in data frame dot which we name as df, we're just reading pd dot read csv. In this we're reading weather aus dot csv file, and we are doing a kind of encoding. That means if this particular data is there which might return some other language, it will be converted into converted to UTF-8 encoding. You might skip this also because mostly it's numerical data, but for sake that we are having this. Now let's run this. Okay, I haven't run the above one library. Okay, now if I run this, it will run. Okay, now to show the data, how the data look like, let's show you. Okay, so we have a lot of attributes, that is for the particular day, for a particular location, what is the min max temperature, rainfall, evaporation, sunshine, wind gust direction, wind gust speed, lot of parameters are there. But our focus will be, which has some numerical data, some has some maybe class data like uh, east, southeast, west, something like that. But our focus is whether rain today and rain tomorrow. So it's a categorical data that it has only no or yes value. Okay, but what we are going to do is for decision tree purpose, since everything mostly is numerical, what we are going to do, we are going to convert this no or yes into 0 or 1 category. Okay, just for the better and for better computation of the decision tree, we are just going to choose, that is like no equal to 0 and yes equal to 1. That's how what we are going to do. So we are going to manipulate some data. So to do that, first the first pre-processing that we are doing is we are dropping the records where rain tomorrow, which is our target variable, is equal to nan. That means for this we don't have data, so we're just removing that because we need since rain tomorrow target variable, we need the data which has proper category assigned to rain tomorrow. To do that, we will modify the df itself. So df in that pd is null is the function we're going to check. In that df, we're going to for that particular rain tomorrow, we will check that, and if it is equal to false. Okay, so what does it means is in the data frame that we are having, I'm checking whether for the rain tomorrow column whether I have a null or not. If it is null, then I'm just removing it directly. Okay, so I'm just dropping those rows and just keeping again the data frame into the variable called df. That's the first pre-processing. Now for other columns that we are I'm going to consider in this decision tree, whatever the missing values are like that, like you can see NaN or any other missing values are there, we are just going to fill them with the column mean. So whatever the column mean will be there, we're going to fill them with that. So like mean, median, mode, whatever it's there. For category, we might see for median, we will check for that. For here, since most of the data is numerical, I'm just going to use the mean, and then that's the first, another pre-processing we are doing. Third pre-processing we are doing is for rain today and tomorrow. These are because these are the target variable. So we are creating another column for those, and then we are just uh, converting no or yes to 0 and 1 for our pre-processing. So just let me write those things. So says that we can work on this particular different column rather than working on rain today and column without changing those original data. We are creating extra columns in that, and we are just appending them there. So let rain today flag, this is a column name for us, and here what we are doing for a column called rain today, for rain today column, we are applying a lambda function, a small function directly, where we are checking, we assign x equal to 1 if x is equal to yes, else assign 0. So that means if else x is yes, assign 1, or else you assign 0. Same thing we are going to do for rain tomorrow flag as well. So for in the rain tomorrow column, so what we are going to do, lambda x equal to 1 if x equal to 1, else 0. So that's the only thing. So we have applied, we had created new column, and then I'll just show you the snapshot of data. And just I will do df. Let me run this. So 3 processing stuff we are doing. First, we are removing the records from rain tomorrow where there's no value is given for rain tomorrow. Second is wherever for other columns, wherever there's missing value is there, we will replacing that with mean, and then we are creating 2 new column, rain today flag and rain tomorrow flag. There we are just replacing what we are doing in the place of yes or no, we are just keeping 1 or 0. So to check that, let's go in the last. So if you can see, rain today, rain tomorrow has no or yes value. Okay, and rain today flag and rain tomorrow flag will consider convert from no to 0 and yes to 1. It will be like that. Now once we did this pre-processing of data, what we are going to do, we are going to define some one basic function called fitting function window. So says that we can reuse that throughout our analysis. So what other function will do, we will split the data into train and test sample. We try to fit the model, that is we try to make a classifier decision tree classifier, predict the label on test set, and generate model performance and create a decision tree graph. All these three things instead of creating different function. We are just going to call one function. The function name will be fitting. So it will have x and y, criterion, what, splitter, m depth, the weight, CL weight, and minimum leaf that you can have. Okay, so x and y will be the train and test value. Criterion will be the kind of metric you are going to use to check which criteria, which subtree is better. So for like we have talked about entropy and Gini impurity, that comes under criterion. Splitter is, there are different kind of splitter is there, something called random, something called best, something like that. These are the by default function names are there. You can check it out in sklearn library. M depth will tell about the depth of a tree. Okay, the classify weights will define the will help us to identify the threshold values, and minimum leaf means you keep on setting the rules till the point you get this number of leaf nodes. So if I think 1000 leaf nodes, you say that till you make 1000 leaf nodes, you will not stop. You will keep on making rules, but also keeping depth in the mind. So these some few criteria that we have to follow. Now what? So first thing is creating a test. Create a training and test sample. Training and test samples. So like what we do, x train, x test, y train, y test. These are the four first categories that we are going to have, and we will call train test split. In this we'll pass x, y, size of the test size will be 0.2, that is 20% of the data we are going to take as test, and random state we are giving as 0. Okay, this is the one thing. Then we will try to fit the model. So fit the model we will do using decision tree classifier. So we have included sklearn import tree. So in that tree import we have a decision tree classifier. So we'll write tree dot decision tree classifier. In this we have to pass on certain values. So criterion, that is like Gini impurity or entropy, whatever the metric you want to see, that whether this the metric which tells us that whether the subtree that you're creating is with less error or not. Then the splitter. Splitter will tell about the number of observations till what you want to split the data. Then max depth, which is come from m depth variable. Then class weight, for each class that we are having, what are the weights will be like. So CL weights, then min sample leaf, min leaf, and random state is equal to 0. Okay, so this is a model with we passing on most of this value, and then passing on, we are trying to fit a model. Well, so first we are giving setting up the model. Now to make a decision tree classifier, we will just do model dot fit, and we'll pass down the value of x train and y train. So here our x value, the values will be all this 17 or 18 features, and the y will be rain today flag and rain tomorrow flag. So these are target variables, and the independent variables, the features that we are having, 1920 features, whatever features we are having, we are going to use that. So once we fit this model, so that's part 1 is done. Then what we have to do is we have to see the performance of the model. So what we'll do, predict class labels on training data. So what we are going to do, it's spread. So based on training data, we are just predicting the labels. So we just do model.predict on xtrain, and we're storing that in pred labels tr. Now predict class labels, that is rain today or rain tomorrow, on test data. So we are saying pred labels te test, and then model.predict x test. Now once we have this, now we can check out for evaluation metrics, that is precision, recall, accuracy and all that. So the tree summary and model evaluation metrics. In this, do a little bit of tree summary, in which we are going to show the classification report first. So first we tell the classes, whatever the class number of classes that we are having. Classes, so clf dot classes, there's the first thing. Then we will tell the tree depth, which we can find using clf dot tree dot and say tree underscore dot max depth. So we'll tell about this, and then we will do for, let me, two more criteria are there, that is number of leaf nodes that we are having, so that we can find using clf dot tree underscore n underscore leaves. Then if you want to number of features that we are considering, number of independent variable, number of features. So in this, which you can directly write clf dot n features underscore n underscore. Now once we have this, let me bifurcate it. Okay, one print statement to give space for that. Okay, now once we have this, now we have to do evaluation of data. So let me write it down small quickly, this print statements. So here it will be evaluation on test data. So in this, we are going to find the score of from test data that we can do using model.score, and then we just pass out x test and y test. We just compare on that, and we just do print accuracy score, and score t will give the accuracy. Now if you want to look at the classification report, to validate the model, so we'll directly use the formula of sklearn metrics. So we'll just do print classification report, and we're going to pass y test and predicted labels in for test. So these two things we are going to pass it out. Then anything else that we have to print? I think almost done. So we have we are printing a lot of stuff in this one function, because we just need to pass certain values such that we don't need to calculate everything. We're defining the model criterias, we are fitting that data with x and y, we are predicting the variables for training and testing, we are we are telling the tree summary for number of classes, number of leaves, feature and all that. We are finding accuracy score, and using classification report we can find out the precision recall values. The only thing remaining is to print the decision tree. So we are using GraphViz library to plot the tree. So I'm using a variable.data tree.export. This is for visualization. You don't have to remember this code, something like that. This is for understanding that how the output will look like once you create a decision tree. Out file equal to none. Out file is equal to none. Then feature names equal to x dot columns, and class names. Class name will be str list clf dot classes 0, and so I'm extracting all the class names as well, and here it's 1. Okay, and the node should be filled with certain color. We are doing that, and that it should be rounded. Corner should be rounded. True. Okay, now once we have this .data file, we just have to print it. So we just say GraphViz dot source. We're calling GraphViz function, and then we're passing this data. Okay, and then we will return the relevant values. So we are returning relevant data for chart plotting. So data would be x return, x train, x test, y train, y test, CLF graph. Okay, so we wrote this function. So quickly summarize what we have done in this fitting function is we are splitting the training test sample data, we are fitting the model with the certain criteria. Then we are predicting the class on training and test data, and based on that we are giving the tree summary, and also we are producing the classification report. Once we get that, we are also plotting the decision tree. Okay, so let me compile it once. Now there's another thing that is for just for visualization that we have written here. So it's plotting 3D plot. We will show based on the features that we are having. We can show the 3D plot for that. Now, if you want to understand this, so what we are having is we have to create a 3D environment. For that, we have to provide certain values for that. So first is mesh size and margin for that, like what are the 3 axes is going to look like, and what is the mesh size. Mesh is like number square values. I will show you the output how it's going to look like. Then once we get this value, we are going to define the range for that. So for each range, we are finding x min, y min, x range, y range, and all those things. Like for each axis, we are defining that how the how we should plot the numbers. So for that we written this code. Once we have this, we are predicting doing the prediction on gain, that whether we can do whether there's a rain tomorrow or not, is there or not. and then we are passing on scatter 3D function, we are passing all the relevant data, and then we are giving a layout like how it should look like. And once we have this, we put the prediction plane for that. I will show you how it will look like. Then we can talk about that. Now, once we have this, once we make a fitting function, because that's a more important thing than plotting a 3D plot, what we have to do is now we will select data for modeling. So at the first instance, we will take multiple instances of data. So type of scenarios. So first will be df. I will take all the variables that we are having, and I'm going to, based on that, I will going to predict that whether we have a rain, whether we're going to have rain tomorrow or not. So for that, so x, in the x variable, x data frame variable, I'm going to pass all the relevant independent columns that we are having. So for this, we have max min temperature, max temperature, uh, rainfall, evaporation, sunshine, wind gust speed, wind speed at 9 a.m., wind speed at 3 p.m., then humidity at 9 a.m., humidity 9 a.m., then humidity at 3 p.m., humidity 3 p.m. So we have a lot of features, so I'm adding all those features. Then pressure 9 a.m., pressure 3 p.m., then the status of cloud at 9 a.m., then status of cloud at 3 p.m., temperature at 9 a.m., and temperature at 3 p.m., and the final this is rain today flag, whether it's going to rain today or not. So based on today's data, we are going to predict that whether tomorrow we are going to get this thing, or whether we are going to get a rain or not. So we define the x variable. Now let's define y variable, which is a single target rain tomorrow flag. Okay, and then values. Now once we have this, so we have to fit the model. So fit the model and display result. So to do that, we will just call the fitting function, and we're going to get the following values, which will be xtrain, xtest, ytrain, ytest, the classifier, and the graph, the decision tree graph, and the following thing we're going to pass as a this thing x, y, this we just has defined, Gini as a criteria, best as a splitter, splitting the data for the rules, depth of the tree, m depth is equal to 3, then CL weight classes, we are not giving any special preference to anyone, so we are saying none. And finally mean leaf is 1000, that is minimum number of leaves that we can have is 1000 leaves of samples. Okay, once we have this, and just the final thing will be that plot the tree graph, and just we pass the graph. So let me run this as well. I think this has been not plot 3D is not run. let's run this. So I have some wrong thing in class weights. Okay, let me check the class weights. Class weights here. I think class weights. I think it's only H. It's not S. So let me run it again. Let me rerun again this. Okay, so we got some output. Let's check for that. So what we have given is we have lots of for a weather. We have a data set for Australia, like Australia weather, in which we have approx 15 plus or 20 plus uh, features, which tells that whether it's going to rain tomorrow or not. Okay, so we pass that with fitting thing with decision tree as a classifier. Now the tree summary is we have two classes 0, 1, that is it's going to rain tomorrow or it's not going to rain tomorrow. That's why 0, 1 is there. Level of depth 3, depth is 3 because we have provided 3, m depth is 3. The number of leaves that we are getting is 8 and the minimum that we can get max till 1000 and the number of feature is 17. So 17 features are there. Now here if we just check that before this, let's see the accuracy. Accuracy is 82%. So for 0th class, that is it's not going to rain tomorrow, the precision recall is pretty good, that is 84% and 97% with good F1 score. But for if it's raining tomorrow, it's showing less recall with decent precision. The reason is we have a lot of imbalanced data. So again the main problem with decision tree is it might overfit the data. So or with less data it might not able to understand, give a proper threshold. So at that point of time these kind of recalls might be less. So recall means in short sense, recall means out of all the actual predicted value, that is for example it's going to rain tomorrow, out all the things, how many instances where the classifier has predicted correctly. So in this case the recall is 0.34. So this is the decision tree where it will start at humidity 3 pm as the basic root classifier, where 3 pm is less than equal to 71.5 with Gini impurity value of 0.348, samples something, these things are there, let's not focus on that. With class 0 is there, class 0 is that it's not going to rain. So from that it is making a decision tree for this till depth 3, and for that we get accuracy score of 82%. Okay, now let's tweak some data for this. Now we have seen for this. Now if you observe this thing, humidity 3 pm and rainfall, sunshine and wind gust speed, these are the basic main variables which is providing us the results in a much better way. So what we'll do, humidity 3 pm is occurring most, so we will take this for sure, and for now let's take wind gust speed. So we'll just take these two variables as x and we try to predict based on these two columns whether it's going to rain tomorrow or not. So let me copy the earlier code directly, and okay, so in this I will remove every single thing, and in x I will just keep two things. First is wind gust speed and humidity at 3 pm. So these two columns we will take and we try to predict for rain tomorrow. Okay, rest of the things are same as it is. So if we just try to print it, let's see the accuracy here. The number of features are 2 because we are taking only 2 features here. Now leaves are number of 8, tree depth is 3. Okay, now the precision accuracy is 82.84, which is similar to what we have seen earlier also. It's 82.4, there's nothing much differences happening. So that means these two variables like wind gust speed and humidity is actually the more important factors compared to other 15 features. with same precision recall value. So what does it tells us that while making this decision tree with all this different 17 features, only these two variables actually affected and make a more role while making a decision tree. This is something you need to interpret from this. Okay, now since we have two independent variable and one dependent variable, we can make a 3D plot out of this. So we made a plot 3D function. So I'm just going to call that plot 3D function, which I'm going to pass x test, y test, our classifier, the decision tree graph. Sorry, x. No, we have to, after classifier we have to pass on the axis name. So like wind gust speed, x2 will be humidity at 3 p.m. mesh size is 1 and margin is 1. So if we run this, so we get this kind of 3D plot, which you can see here. I can rotate it also. So to understand what does it mean, and let's see. So let's assume this. No, not assume. Consider humidity 3 p.m. as x-axis, wind gust speed as y-axis, and probability of rain tomorrow is z-axis. So when 1 is there, the 1 point, you can see the black dot above, that shows us that the instances where the rain is going to happen tomorrow. And if you see the zeros, the black dot has 0 value. This case, this shows us the probability of not having rain tomorrow. These are two classes that we are having. So this is one thing to observe. Second thing to observe is, you can see a kind of steps are happening. So when as the probability of this increasing, there are different kind of steps you can see. These steps are basically the threshold values. So at particular time of humidity 3 p.m. and wind gust speed, at that point we put a threshold based on which we found a probability of 0.060. Then again we at particular point of humidity 3 p.m. and wind gust speed of 52 and 52, we are getting threshold of 0.44. Probability of rain tomorrow is 0.44. Like that, there are a lot of steps are there. These steps define the different kind of threshold that has been decided to define that if my probability of rain tomorrow is increasing, what are the criteria of humidity 3 p.m. wind gust speed are involved. Okay, so that's how you can look at it for interpretation and look for size. You can spend some time while working out for this. Otherwise, you can skip this also. This is just for exam telling that I can't show it for more than 3 variables, because our perception to look at 3D, we can only look at 3D object. We can't look more than 3D or 3-dimensional space. So we can't plot it for more than 3. So that's how we can see for that. Now till now what we have done is, for that data we are having, the depth we are keeping as 3. We are keeping the fixed depth as same as it is. So if we keep the depth as unlimited, then what will happen? Let's see that. So if I put only, I need to change this m depth equal to none. If I'm keeping this, so I will just just put this card classification model with unlimited tree depth. So let's see what will the accuracy score will look like. Okay, so it will be like accuracy score has been decreased, not drastically, only slightly, that it is from 84 to 83. Precision recall for not having rain tomorrow class has increased slightly. Same for rain happening tomorrow. Positive, for positive class is rain slightly, but not that much difference. So that means even I have unlimited depth and I include and I'm having two features or maybe more than two features, the accuracy has not been changing much. So that's why when we are trying to create a decision tree, you have to see the you have to find out the best possible way, that means with least number of features, how you can predict the target variable. And now this tree will be very big, so I can't show it properly here, but considering that it's very horizontally very big, um, it is starting from here and I keep on scrolling. So unlimited depth, it's not like unlimited will be there, at certain point it will stop, but the depth where we are not restricting, where it will stop automatically, where it find that it can't split anymore. So at those instances it will find out and it will try to create. So this is a depth for unlimited tree. Okay, so it's almost at the end of session. So let me summarize what we have done in this part. So what we have done is we have taken a data set of weather, from based on which we try to create a decision tree which tells us that based on the whatever features we are having, we're trying to find whether we are going to have rain tomorrow or not. For that we are creating a decision tree. Now for that what we have done, we did some pre-processing where we have removed certain records where rain tomorrow, that is a target variable, doesn't have any value, one thing. And for other columns we have replaced the missing value with its mean, and instead of replace, for better computation, instead of having no value, no or yes value, we are just replacing no yes value with 0 and 1. That's the pre-processing we have done. Once we did this, we create a fitting function which do this 5 step, that is split the data into train and test sample, fits the model, predicts the label on test data, generate the model performance metric, that is using classification report, and using GraphS we create decision tree. Okay, this plot 3D is just a extra function that we use just to show you a 3D visualization, how you can visualize a decision tree in the 3D space. For that this is there. And then we have used different kind of we play with different kind of features with X and Y data and try to create a decision tree with different features, like with different criteria like Gini criteria, best criteria, depth of the tree, weight of the classes and all that. So based on that we have tried multiple things. Okay, so let me see if you have any question. Mostly, yeah, they might provide the values for t test or f value table, chi value table. They will provide. They will provide certain hints from which you can directly use it. Okay, so uh, see if the I know that this has been told to me earlier also by the students, but that is something I can't do anything about. That only the NPTEL and the faculty in charge can do anything about that. So if you have done the discussion forum, I hope they will check out that. Otherwise, keep sending mails to NPTEL. They might reply it back to you. Okay, so thank you. So today we discussed the classification decision trees for classification regression tree. So this is the second last session. The next session I will be taking on Friday. Uh, you might not have to write the Python code in exam. You might have to write a small snippet for that, but not the whole code, like what we are doing. What I'm doing just for demonstration purpose. You might not have to write this much amount, big amount of code, but you should know the functions library, which basic functions which you have to use to write the Python code. Like for example, for decision tree, I just need to write one single line of code defining multiple criteria. So that is something you have to remember. Okay, so any other question? Okay, in that case, I'm ending session for everyone. Thank you everyone for joining.